Bit over
Collaboration.
Great, thank you. I'll speak up a bit so everybody in the back can hear me. Good afternoon, my name is Berke Bout. I'm from the company called Contracts 11. Who's here? One question I've had, who here in the audience has written any code before? Has written code. It's fine. There'll be some code in here, so don't be afraid. There's a lot of slides, I'm afraid, as well. I'll be discussing my company, but also what's interesting about the blockchain area at the moment. And raise your hand if you have questions. I'll rush through it. If I go too fast, let me know as well. I'm known to speak too fast, so I'll try to do it better this time. As I said, I'm from Contracts 11. This is me basically. I've done communication science, AI, and a PhD in distributed systems. I've been working on software for the internet for about 25 years. I've done it in different settings, commercial companies, research institutions, academia, etc. I've been a father of 3. I'm an actor, I'm a musician as well, which is my hobby. I've had a ticketing company before this one called PayLogic. You might know it. It stands for big companies, big ticketing systems. Sold it to an American billionaire. It was a lot of fun. But now I started a new company. It's called Contracts 11 in the blockchain area. And the basic goal of the company is to build what we call Web 11. Web 11 is an idea to build a better internet because we think it can be a little better than it is nowadays. I'm a founder of 4 companies now. It's immediate to be Contracts 11. Exciting. Exciting is an Internet of Things business. We've heard Internet of Things before today. I hope more than 3% know what it is. And B11. B11 fun is if you write it out, it's called B11. It's called like Beleven, and it's a marketing company. Of course. About Contracts 11, it's founded in 2014 in Groningen, as well literally it's from, so I'm with the train as well this morning. We're software professionals and we're developing tools and methodologies to build better systems. And we have innovations in data and process modeling, and we build smart contracts too. We see smart contracts and blockchain as just one tool that you can use to build better processes. And we've applied this stuff for real critical and life-saving systems already. We build software, so we're builders, we do consultancy training, and we're part of the Media 2B group. Bottom line is we build software, that's what we do. We have been doing this for many years. I've been doing it for 25 years. My partner in crime has been doing it for over 40 years. I think a lot of the discussions around blockchain have to do with software development and the tools and technologies that are common there, and we can learn from that. So what I think the biggest challenge with blockchains is, let's see, I think 99% of the use cases floating around are unattainable or either doable with regular IT. Might come as a shock, but it's my finding. For instance, I have a company called Contracts 11. We want to build this stuff. We can build this stuff. We've proven to build this stuff. We can improve this stuff. We'd like to work in this area, but we can't really find companies that are really asking that the real need for something that can only be solved by a blockchain. So who in the audience, for instance, works for a company that really needs something implemented, done, and not like a proof of concept, and not like a training, and not like a presentation, the real software. So anybody here in the audience that needs that? There you go. Nobody really needs it. Anybody only wants to talk? Well, there's one in the back. We can talk maybe later on. I think we have to challenge and identify the importance of 1%, because there is a very interesting area in blockchain. It's really a unique idea. I think the most valuable thing in blockchain is that the creativity that it spawns and the ideas that it generates. I think that's one a big asset that it has. But then again, companies that want really something built on blockchain is very rare. Contracts 11 aims at that 1%. We want to build it, as I said. We're still waiting for companies to say, okay, I need it, I want it, you have to build it first now. Because we can build it, we have proven that it's there, the technology is there, whether it's Ethereum or it's blockchain.
Are you suggesting to build a blockchain, like a separate private blockchain, or are you trying to suggest
no, solutions
application on top of blockchain?
Exactly. If you need a process that can be improved, for instance, by using parts of the blockchain, then we're your partner. If you have, for instance, you're a hospital, so we want to keep some data secure, for instance, and it's part of a bigger process, they can hire us. Because we always think about big process, and blockchain basically is just another technology that we can use to improve these systems. We're not going to build blockchains because there are already a lot of effort into that. It's too big, too much, but we can use it. But we're doing other, as I said, the biggest current market is if you're talking about blockchain, that's what I said. But in the meantime, there's important work to be done on the blockchain. I'll talk a bit about what we think it is. First, you have to take a step back, because as I said, I think the most important and interesting aspects of blockchain have a lot in common with the most interesting challenges in software engineering. And the question why we need so many software engineers, as we all know by now, is that there's a gap between the problem owners and the one implementing the solution. Most of the work in IT and software engineering is because there's somebody has a problem and there's somebody else that has to implement the solution. And there's a big gap, because he can't really, the one that has a problem can't really state what he wants, and the one that has to implement it has to interpret what has been said, and almost all work in IT is trying to close that gap. It's very well known. Have you ever built systems either for banks or for hospitals or whatever it is, you always bump into these problems. Idealistically, problem owners should be able to program their own solution. That's the ideal. That's the ideal that we're working for. Ideally, what you want is the guy that has the problem can express himself in such a way that what he writes down is directly executable as a program, as software. Contracts 11 works on methods and tools to do this, because it is attainable. But it goes back, we had a lunch discussion, it goes back about to the 60s, basically, in the 50s, when the first computer languages were written down. Like COBOL as a language is it's very specified. It's designed to be able to be used by domain experts to express themselves to build systems. So closing that gap was already implemented in COBOL, and it's a language that's very old already. The thing is, this is useful for smart contracts as well. Everybody knows what a smart contract is, I assume. Sort of like knows what it is. Right? Let's assume it's a program, right? Well, there's different. There's a contract, you have a smart contract, and you have smart contract code. You just get the stuff clear. You don't have to read the small print. This is what basically a legal contract looks like. We all know the way that it's written down. If you look at smart contracts, the code that I like, that I found is the use of code to articulate, verify, and enforce an agreement between parties. It's called a smart legal contract. It's a combination of smart contract code, so it's a combination of code and more traditional legal language, basically. Because not all aspects of a contract can self-execute. Now, this is what the smart contract code looks like, basically. It's for program. It's very readable. It's very simple program, actually, and anybody can read it. This is in the Solidity, which is the language you use to write contracts on Ethereum. It's based a bit on JavaScript, which is a very awkward question, very awkward choice if you ask me. I'll dive into that. But this is how this is what contract code looks like. Unreadable by lawyers. So the difference between contracts and code, there is a difference, because contracts are readable by lawyers. Lawyers design contracts, they write them down, they have to formalize language. And in case of an exception during the transaction governed by the contract, everybody knows what to do. This is what a legal contract looks like. Very simple, this is basically what it is. On the other hand, code, it's written by programmers. It's understandable by programmers only, and most likely contain bugs because all software does. And if something goes wrong with code, then it's very unclear what to do. You call the help desk, or your system breaks down, or your money is lost, or whatever. It's unclear. If you look back at contracts compared to code, there's a world of difference in there. The strange thing is that with smart contracts, they try to merge these two worlds. Unfortunately, basically, smart contracts have a big responsibility. Let's understand smart contracts. Data in a blockchain needs to be created, updated, read, just like a database, and then while maintaining its integrity. That's the responsibility of a smart contract. That's what it should do. So the smart contract manage the data in the blockchain, and the data in the blockchain can be very sensitive and valuable. It's very easy to understand. Look at the Bitcoin transactions. If something goes wrong in the contract, you can lose all your money. But if you use the stuff for insurances or for healthcare, whatever, these consequences become bigger and bigger and bigger and bigger. One of my other companies is called Exciting, and Exciting builds Internet of Things solutions. What you see with Internet of Things revolution right now is that more and more stuff is connected to the internet. But the problem is, if this stuff is being hacked or being misused, the consequences are getting more and more severe. It wasn't a big problem if somebody hacked your email account, but it is a big problem if somebody takes over your baby phone or your heart monitor or your car or your house or your, well, I don't know what, your traffic light in your town or the water supply systems. And these are not just thought of ideas, these are really actual things that are happening right now. The basic problem is that the underlying systems that run this stuff is breakable, is hackable. The same goes for smart contracts. Smart contracts have a very large responsibility, is that to maintain the data in the blockchain. If the wrong stuff gets in, the consequences can be really, really big. So we should really be able to understand these contracts. It's essential for the users to fully understand what a smart contract does. If you don't understand, consequences might become very severe. Consequence again is that if you want to write smart contract code, as it just showed, and you want to know exactly what it does and how do you write it? If you do it in computer code, it's problematic because only programmers understand that stuff. Coming back to computer science, there's a very simple rule that applications, and there's also smart contracts, should be specified, written, should be tested. And it should all be done in a very solid software process. And these processes are, of course, constantly on the change. Now they're all agile again, and it's constantly. It's one of the areas that's really fast evolving. But in general, this is the way that software engineering works. If you look at writing smart contracts with this in mind, the problem is if you apply this software engineering practices to writing smart contracts, and these smart contracts do have a code component in them, as we just saw. There's some problems with it, because specification and implementation are one. And I've given Solidity code for an Ethereum contract as one example. Ethereum contracts are written in Solidity or Serpent, another flavor of programming language, which programming these languages. But the specification of what it does and actually implementation of the system that does it is one. And from a computer science perspective, that's problematic. Basically, you want the expression of what it should do, and the machine that does it should be separated. Because you want to maybe run on multiple systems, but also maybe because you want to be more in control of what it actually does. The specification therefore can be limited by and influenced by the target platform. Yes. Thank you. Second point, domain experts have no way to express their requirements. As I just said, domain experts are not programmers, so they have no way to express their intent in code. They can't program, but they do know how to set up a legal document. But these are worlds apart. And last point, programmers who cannot verify that implementation satisfies both the contract requirements of the domain expert. So if a programmer gets some requirements document, he has no idea to interpret the document because there's, as I said, there's this gap between these two worlds. So in the end, both programmers and domain experts are working in the dark. This makes it likely that errors will be introduced, and that is problematic because these errors will have their effects. And there's also a problem with testing. As I just said, testing is an integral part of software engineering. If you don't test, you're in the dark as well. You don't know what your system does, and you don't know if it adheres to things that you've promised that it should do. You should be able to use standard testing methods and tools, and it should be absolutely clear that when all tests fail, that the contract passes and it behaves as it is tested. So if your application passes all the tests, then you are assured that it adheres to the contract that you've written down. But if there's a difference between the implementation and the contract, the chain is broken, and that's really problematic. So how do you do that? Is there a way to do so? We at Campus 11 designed a new language, and it's called ACE. And we call it semantic programming for smart contracts. And we at Campus 11 are all about semantic programming. Semantic programming means getting out of the level of code writing with curly braces, etc., onto a level that's very more semantic, it's understandable for the domain experts. And one obvious area to apply this is, of course, smart contracts. Because smart contracts, as I just explained, are very important to get them right. And that's so you can't really trust some programs to implement them in the correct way. So programming smart contracts should be in a language that is one level up. We call that the semantic level, semantic programming. And we've been diving into semantic programming languages for about 40 years. So it's not an unfunded idea. It's an idea that has been well thought about. And we're world experts in this area. We've applied them to smart contracts. It's called ACE, and it stands for Automated Contracts in English. And you specify the contract in a structural natural language, like legalese English, for instance. So it can be written, read, and validated by the lawyers, by non-programmers. And we've built compilers that compile that stuff into a target platform. This time, we built it to compile into Ethereum contracts. So the compilation, if you write a contract in this ACE language, you can compile it, and the result of that is either a skeleton implementation of the contracts themselves and tests. The nice thing is, the only thing the developers have to do after that is to finish the skeleton implementation while ensuring it keeps passing the tests. If the implementation keeps passing the test, you are assured that it adheres to the contract. There's no way around it. So passing a test means your contract is fulfilled and your code does well as it has been advertised, which is really unique. So the result in the end, there's no developer needed for the translation. Programming errors cannot be introduced, and the test pass means that the contract is fulfilled, and this is truly revolutionary if you ask me. And it's something that we really need in the blockchain area. And also, as it pointed out earlier today, we have accountants here, and with people from the finance industry, and with software developers. These are really worlds apart, and we need to get these worlds together. Blockchain is sitting there right in the middle, and is on the one hand waving to the developers, on the other hand waving to the financial industry, and they're not really connected. This is a way that you connect them. It also guarantees things about your system, about your contracts. And it's something that we need for our future systems. Our future systems, we will depend more and more on our future systems for our health, for our safety, for our money, for whatever it is, for our government even. I mean, all these ideas that are floating around, we are depending on these systems more and more. So we want to make absolutely clear that we understand what they do. That is guaranteed that they work correctly. So the benefits of the approach that Connex 11 takes is that because the readable specification language compiles directly into the implementation and tests, the domain expert knows and can verify that the implementation contract does do what it and should do what it do, which is really unique. As you get fast feedback as well, we work in an agile method. That's more detail, and risk is minimized. It's not just talk, we've implemented systems with this as well. We've done it for the insurance system. Of course, having had a ticketing company before, we've done it for ticketing as well. We're doing it for notaries to get, okay, does this approach work and does it help us? I'll give you an example, ticketing. So in ticketing, an organizer can create a contract, can add tickets to it, you can sell tickets, and you can assign a scanner to that. The customer can have a ticket, it can be scanned or it can be unscanned, and they can transfer an unscanned ticket to a customer. Very simple use case. There's also a scanner, one at the entrance of the venue that scans the ticket. You can scan an unscanned ticket, or you can unscan and scan the ticket. Basic ticketing can be much more complex than it is, but in the basis, this is ticketing. So everybody then can observe that, can observe the total number of tickets, can observe the number of unsold tickets, and the number of scanned tickets. We give an address of does it have a ticket, and if the address has a ticket, is it scanned or is it not scanned? So that's for everybody. Now this is what a contract then is. Slide 1 or 2. This is the ticketing contract in the language ACE. So you specify the number of contracts, so whatever the number of tickets, so the number of scanned tickets, what's the account is organized, is a certain account, is it the organizer of the event, yes or no, so true or false. You initiate some data, it creates an organizer or is a scanner, and then some statements that must be met at all times for all accounts scaled. It must not be true that the account has a scanned ticket and he has an unscanned ticket. Well, very simple rules like that. Let's set them up. Another condition is that must be met at all times. The total number of tickets needs to be bigger than 0. Slide 2. With the system defined, you can ask queries to the system. A query like what's the total number of tickets, and you provide that the initiator of the question is the organizer, and the answer will be the total number of tickets. This is how you program in ACE basically. And it's, as you can see, structured English. A lawyer can write this down and make sure that the system does what it does. Operations then become, you can do stuff, you can do operations. One operation, for instance, add the number of tickets. And again, can have provision to that, saying that the initiator must be the organizer, and the result will be the total number of tickets and the number of unsold tickets, and this is how you specify these operations. As you can see, it's very, even for non-programmers, it's an understandable language, it's something that you can do and use. So this is the ACE contract for ticketing. This is I've slipped a few pieces up. I think it's one over the half of the whole contract that does the whole ticketing system. That's it. And the thing is that it's readable for non-domain experts. The next thing is, how do you go from this system to a working contract on Ethereum, on a Bitcoin blockchain, or whatever the next system comes along? You have to compile this stuff into the target platform. So we've written a compiler that compiled these kinds of contracts into systems, and we've given an example here. This goes to Serpent. As you see, this is the compiled version of the contract. And the example is it's being compiled to Ethereum, and Ethereum has a language called Serpent, and Serpent looks like this. It looks like programming language Python. I am actually the organizer of the biggest Python conference in the Netherlands, so with fancy Python-like languages, but then again, it's just a sidetrack. So we chose an example, this as an example, but there's other languages as well. You've seen Solidity, another language you can use. It's very Java-esque like. I don't like it. Anyway, so it runs like this, and as you can see, this is way more regular programming language, much more ununderstandable, but this is what it compiles to. And it doesn't only compile the system, but it can run directly on the Ethereum blockchain. It also generates the test. And the nice thing is, this is the example of the test. We don't have to understand what it says. These are these two slides, but you need to understand that these are the tests that test your implementation. And as long as these tests pass, you know for sure that your application, you meet your contract. So anybody that gets your application just can test, okay, does it pass these tests? Then it adheres to the contract. It's an argument, there's no way around. You can't fool the system. You pass the test, the contract works as advertised. And that's quite unique. Well, you can still specify your contract in a very understandable language. So the wrap up is, we need to close the gap between the problem owner and the one that builds a system that solves it. We need to close the gap. It's a very general computer science problem that has been, slowly there has been some effort in it, and we need to get there. And with smart contracts, you see the same problem as well. We need to close the gap because the stakes are getting higher and higher and higher and higher. Especially if some of the, with the Internet of Things example that they just showed, the stakes are getting much more higher. You want to make sure that it works as advertised. So writing and reading these smart contracts should be doable, but the problem owner, the domain experts, and Contract 11 has a revolutionary tools and methods for closing that gap. That's what we do, that's what we build. And we see blockchain just as one thing that we've been doing. It's a technology that we can use, that we can apply this stuff to, but we do other things as well. We offer working software, mission life critical systems, we have world-class experts, methods and tools. We do blockchain and fintech technology as well, it's one area. And we're both experts from academia and industry, because as I said, there's a lot of research going into these languages, how you specify them and how you build compilers for that stuff. And there's idealism as well in Contract 11, because Contract 11 is part of a bigger movement, which we call Web 11. Liquid is connected to it as well. It's a bunch of active people in Groningen. We understand that if you want to be, now that we're going into the future and the internet is becoming more and more part of your daily life, the stakes are getting higher, but the way that we develop these systems is problematic. The way that we develop software, the way that we go around with data, the way that we mess around with privacy and identity, there's no clear concept. So, and we think that the core problem is not, the solution cannot be in the parts of the whole system. The solution should be in the whole of the system. So it's not, you can't say to a manufacturer of a smart device, you should make the smart device even more smart or even more secure. That won't work, because they go out of business and they lose you, your contract gets out, etc. So you're sitting at home with a smart thermometer or with a smart energy meter, and nobody's responsible for anything. It doesn't update itself anymore, nobody feels responsible. So the solution is not going to come from giving the manufacturers of these things more, telling them that they should create better units. I think the whole system, the way we develop the system, should have some kind of DNA that prevents this kind of use. That should be self-healing, that should prevent misuse of the system. And that's what we call Web 11. And it has all kinds of aspects, from artificial intelligence to networking ideas to blockchains in there. So it's a conference around these ideas. If you look at Web11.org, you can read more about it, about these ideas. But these companies that I've talked, Contract 11 is one of them, these companies work on this idea. You look at more up on on the company itself, contract11.com, if you'd like to, and read up more. And if you have really concrete questions, then come up to me and we'll talk. And especially if you want to have something implemented, as you just asked, you know where to find us.